So here we have a rate of change question which involves a triangle with whose sides are increasing or decreasing. Doesn't matter, question can be framed in different ways, but it sort of follows the same process, which is you have a triangle, you have sides, and some part of it, either the base or the, in this case it's this point over here, is changing. And so they're asking us for that rate of change. In this case, that is the vertical and horizontal. So in all of these questions, we got to find an equation for the relationship between the sides, and that equation we can find the derivative of, and we can plug in values. So in this case, we have a triangle which is sort of this way. So you have a yellow triangle, let's say, which is the bigger triangle, and then you have a smaller triangle, which is, and so I'm looking for the equation between x and y, say, that I can find the derivative of, and for that I needed a y first. So since they're asking for the free top end of the ladder, we definitely want to call this a y, and we want to see how fast that changes. So this is sort of the setup we have here. We have two triangles. We have the yellow triangle, let's call it the yellow triangle, which is triangle 1, say, and we have got the black triangle, which is triangle 2. And what you have there in that case is you have these two triangles which share a common vertex, and that vertex is this vertex over here, and so they both have a common vertex here, and so you have x here, you have 3 here, you have y here, and you have 10 here. Does that make sense? Hopefully that makes sense. So we have two triangles. They're similar because they share a similar vertex, and because of that you can use a nice little handy property, which is the ratio of equivalent sides are equal. So what does that mean? That means we need to find equivalent sides. So what's an equivalent side of the two triangles? These two sides are equivalent, sort of on the same side, same part of the triangle. This is the high part of the big triangle, this is the high part of the smaller triangle. So what this says is the ratio of equivalent sides. So let's do y over 3 equals, so that's this side over this side, equals, and we need something that relates x to y. So we could go for this side, but then we don't know what this side is for the yellow triangle. Instead, we can choose this side, and we do 10 over, and you just have to find out what this side is, and this by Pythagoras theorem is x squared plus 3 squared. It's the hypotenuse, so it's the sum of squares of the two other sides. So I hope that makes sense. This is using the property of similar triangles, and we get this nice handy equation. And from here it's you just have to solve it whichever way you find comfortable, and you have to get a derivative of this equation. The way I find it easier is I cross multiply. So I multiply this term by this term, and I multiply this term by this term, and I get them all without fractions. So I get root of x squared plus 3 squared times y equals 30. And what does that imply? That implies that if I want to find the derivative, I have two terms on the left side, two variable terms, and then I have just a constant term on the right. So to find the derivative of this is my first term, this is my second term. I use product rule. So what does the product rule say? First term times derivative of the second. So first term times derivative of the second. So first term I write as is, times derivative of the second. Derivative of the second is y prime, or dy over dt. We are finding the derivative with respect to time. How do we know that? It's meter per second. Usually I have a method I follow with students, but I haven't really read through the question with you. I'm just assuming you're familiar with this question. So first term times derivative of the second plus second term times derivative of the first. Second term is y times derivative of the first, which is a power rule. where x squared plus 3 is raised to half. So that just becomes half times x squared plus 3 raised to half minus 1, which is negative half. So that we've done the product rule to find the derivative of the left side. The right side derivative is 0. And so we have this term over here, a little bit of clearing, and we get this term stays the same, plus over here we can sort of clean this up to look like y, oh yeah, times derivative of the inside term, right? I forgot the chain rule. Derivative of the inside terms times 2x. The 2's cancel, so you get y times x. You get x times y here over, so this y times this x. These 2's have cancelled, and so to make this positive, you take it to the denominator, so you get x squared plus 3. And when you do the derivative of the x term, you get a dx over dt. I haven't really explained that well, but I hope that makes sense. So x squared plus 3 times dy over dt equals 0. So this is the not so elegant equation you get trying to find the derivative, and so that we can find, what are we looking for? Dy over dt, the change in y with time. And so now what are the values we know about? The values we know about, we need an x to plug in, we need a dx over dt to plug in, and we need a y to plug in. So what are these terms? They give us, in the case, the bottom ladder is 4 meters away, so x is 4 in this particular case. So we have a 4 we can plug in, so x is taken care of, x is taken care of, x is taken care of. Now we need a y and a dx over dt. What is dx over dt? Dx over dt is just the change in x with time. Right? X is the bottom of the ladder. So the change in x with time, that's 1 over 5. So we have this too. So now to find this one term, you just need all of the other terms, and the missing term is the y. So we need to figure out what y is. And is that hard to do? That's not really hard to do, because we know that if this is 4, by Pythagoras theorem, this becomes 5, right? So it's the square root of 3 square plus 4 square, which is 5. And this is 5. So now we can use similar triangles, and we can say y over 3 is equal to 10 over 5. The same idea that got us this equation gets us this. And so we get y equals, hope I did that right, y over 3 equals 10 over 5. And so we get y equals 6. And since we get y equals 6, now we have all of the terms, we can plug all of them in, and that should get us the answer. This turns out to, what is x? X is 4. So this 4 square plus 3 square root of 25, which is 5 dy over dt plus x times y. X is 4. Y is, we just got 6 over 5 again. Dx over dt is 1 over 5 equals 0. And so we get this term, we can hold on to it. This becomes 24. 6 times 4, 24. 5 in the bottom, 5, 25. So this becomes 5 dy over dt plus 24 over 25 equals 0, or dy over dt equals, I move this to the right side, this becomes negative 24 over 25, and then I want to get rid of the 5 from here, so I divide both sides by 5, so you get 5 times 25 in the bottom, which is just negative 24 over 125. I hope that makes sense. That was a little rushed to find some time. Usually I would say go over a 3-step method, but anyway, that's the solution.